Hi everyone, so right now I'm going to go over how we can solve two systems of equations using substitution. So a simple example would be, say we are given the equation 1, x equals 5, and the second equation 2, y equals 2x minus 3. Well, because we already know that x equals 5, we can substitute x equals 5 into the second equation. So what we get is, going and using the second equation, we can say y equals 2 times 5 minus 3. And evaluating that, we get y equals 10 minus 3, and y equals 7. So solving for this systems of equation, we have x equals 5 and y equals 3. If we were to graph these, okay, so this is kind of reviewing how we would solve the system via graphing. But if we have 1, 2, 3, 4, 5, we have our line x equals 5, and we have a line 2x minus 3, 1, 2, 1, 1, 2, 1. So our system would intercept at 5, 7. That's what solving a system is. It's saying if we are given two lines, where do they intersect? Okay? This right here is solving systems using substitution. So let's give a different example. So say we have an example where you're given one equation, 2x minus 3y equals 7, and another equation, negative 3x plus y equals negative 7. So here, unlike the first example where we're given x equals 5, we're going to have to manipulate these two equations, or one of these equations, and then substitute it into the other. Okay? So the notes for substitution is you need to manipulate one equation. So for example, solve x equals or y equals. And then the second step is you plug it into the other. So in this example, we are going to choose the easier one to manipulate, which is the second one. So using this second equation, we can add 3x to both sides. And when we add 3x to both sides, we get y equals 3x minus 7. Now, even though this isn't a number, we can still use it to substitute into the first equation. So let's go ahead and do that. So using the first equation, this is the second one, we have 2x minus 3, and instead of y, we're going to write 3x minus 7 equals 7. Okay, so now we have 2x minus 9x plus 21 equals 7. That gives us negative 7x equals negative 14. Because we're combining like terms here, and then we're subtracting 21 on both sides. Then we divide by negative 7, we get x equals 2. To solve for y, we can plug that back into this guy. And so we got y equals 3x, which we know is 2, minus 7. So y equals 6 minus 7, which is negative 1. So y is negative 1. So that means graphing these two equations, they would intercept at 2, negative 1. Okay? I'll do one more example. And here we have the equations 3x plus 2y equals 1 and x minus 5y equals 6. So if we have these two equations, we can use the second one and solve for x. So if we add 5y to both sides, we get x equals 5y plus 6. We can plug that into the first equation, and we can get 5y plus 6 plus 2y equals 1. That'll be 15y plus 18 plus 2y equals 1, which gives us 17y equals, subtracting 18 from both sides, negative 17. So y is negative 1. And since we know y is negative 1, we can plug that back into x, and x equals 5 times negative 1 plus 6, which is negative 5 plus 6, and x equals 1. So that means that this systems of equation, these two lines would intersect at 1, negative 1. Okay? So solving systems of an equation, you are going to manipulate one equation to solve for the variable, and then plug that into the other equation, okay? And that will let you solve for both variables.